All right, so permutations are a pretty straightforward application of the multiplication principle. I'm going to, in this next set of examples, I'm going to sort of build up a little bit more of a uh, complication when we have indistinguishable elements. So example 6 is just pretty straightforward. We're asked how many ways can you arrange the letters in the word bolt. Okay, so we have a B, we have an O, we have an L, we have a T. So it's sort of like arranging the books on a shelf. You know, we're gonna, okay, what do we want for the first letter? We have 4 to choose from, right? So we have 4 choices for the first letter. Okay, now we've used 1, so now we only have 3 choices left, and then 2, and then 1, right? So this is just a permutation of 4 things taken 4 at a time. And it's easy enough. We can multiply that out and we get 24. All right, so that's easy. And I've actually listed all 24 arrangements here in preparation for the next example. All right, so what's happened in the next example? Now I have the word boot instead. It's the same question basically. How many ways can you arrange the letters in the word boot? Okay, the trouble here is that we now have these 2 O's and they're really indistinguishable from each other. So here's what I did in this little table here is I made those 2 O's distinguishable by calling one of them O1 and one of them O2. Okay, and you can see then if they're distinguishable, then we really have the same 24 permutations. But you can see I also paired these up. You can see that for every pair, if I take away the distinguishability of the O's, take away that O1 and O2, and make those O's indistinguishable, those are really the same arrangement, right? Here's this one reads boot, and this one also reads boot if I take away the distinguishability. This one reads Boto and this one reads Boto. Either way, no matter what arrangement of the O's you have, it reads the same because the O's are really indistinguishable. Okay, so when you have indistinguishable elements, you have to divide out those duplicates. Okay, because we get these duplicates. In this case, there are 2 ways to arrange the O's, right? So I need to take the permutation of 4, choose 4, right? But I'm going to divide out the number of ways to arrange the indistinguishable O's. Okay, so we have 4 factorial over 2 factorial, which is just going to be 4 times 3 times 2 times 1 all over 2 times 1. And so you can see then that's going to cut the number of permutations in half. So we end up with 12 permutations, which you can see just from the table because I've arranged it so that you can see the duplicates next to each other, right? And it all has to do with just the arrangement of the O's, all right? That's the only difference between these words that are side by side. Here's Tobo, here's Tobo. The only difference is the arrangement of the O's. And for any given set of, or any given arrangement, there are 2 ways to arrange the O's, so we have to divide by 2. Okay? All right, so I'll meet you in the next video.